Hello, this is Dr. Phil Rosenkrantz again with EGR 403 Online. This is presentation number 9, which is about rate of return analysis, which is chapter number 7 in your book. Please go to slide number 2 and we'll look at our big picture again. You'll see that we're on chapter 7, which is our third analysis method. Just a reminder that these analysis methods can be used for the same problem, should give you the same answer, but they have different uses depending on the circumstances. And I'm going to illustrate that a little bit with the next slide. Please go to slide number 3. We've talked about present worth analysis and annual worth analysis. Now, internal rate of return or rate of return analysis, basically what we're doing, just a little quick preview, is if you look at that formula in the box, a present value equals uniform series times the P over A factor for I% for n periods. If you'll recall, we have 4 different variables in there, and if we know any 3 of those 4, we can find the 4th one. And here is the case where we're solving for the unknown interest rate if we know what the present value is and the uniform series and the number of periods. So that's the direction we're heading in, and that'll be illustrated with example 7-1 very shortly. Please go to slide number 4. So what is the internal rate of return? It is the interest paid on the unpaid balance of a loan such that the payment schedule makes the unpaid loan balance equal to 0 when the final payment is made. And for an example with a present value of $5,000, interest rate of 10%, and n equals 5 years. If you recall, this is one of our examples from the equivalence module earlier. You'll notice that in the 5th year, the amount of principal owed is $1,199.08, and in the very last payment, that's exactly how much of that last payment goes toward the principal so that the balance goes to 0. And so I, 10%, is the rate of return that makes that happen. Okay, let's go to slide number 5. How do we calculate this internal rate of return? There are several ways to do it. The approach we follow is to choose typically one of these 5 formulas, one of these 5 identities. They're all equivalent. They're slight algebraic derivations of each other. We pick whichever one we think is the easiest one to work with, and then we find the interest rate that makes those identities hold. For example, let's look at example 7-1. Please go to slide number 6. What we have is a cash flow where we've invested $8,200 and we're going to get a benefit of $2,000 a year for 5 years. So we have a uniform series, an A series, of $2,000 for 5 years. And we want to know what interest rate, what internal rate of return we have here. And so in other words, we've invested our $8,200, we're going to get $2,000 a year. What's that rate of return? If we choose to use the formula present worth of benefits divided by the present worth of costs equals 1 as our identity to solve for the unknown interest rate. So if we plug in what we know, the present worth of benefits is 2,000 times the P over A factor I% for 5 periods. That goes in the numerator. The denominator is the present worth of cost, that's the 8,200, and that has to equal 1. So the P over A factor for I n periods equals 5 is equal to 4.1. In this case, the way we solve it is we go to our tables and we want to find on which interest page that factor is closest to 4.1. And you'll notice that, in fact, at the 7% table, the factor is equal to 4.1. So our unknown interest rate is 7%. So that's the simplest, easiest example where we have one factor and we can go to our tables and dig around till we find where the interest rate is. So let's go to slide number 7. This is example 7-2 in your book. Now we have a mixture of a gradient and a uniform series. And if we set up a formula where we choose the identity EUAB minus EUAC equals 0, we end up with an equation that has two factors in it because of decomposing that cash flow into the gradient and the uniform series. So if we want to solve for that unknown interest rate, we can't just solve for one factor and go flipping through our tables. What we have to do is use the trial and error method. Please go to slide number 8, and here you see how we're going to go through this trial and error method. If we try 5% as our first attempt, and we look up the factors for A over G and for A over P at 5%, plug those numbers in, we end up with an EUAB minus EUAC equal to plus 11. Well, that's too high of a number. We were shooting for 0, which means that the interest rate we chose was too low. Well, let's try a higher one. Let's try 8%. If we plug in the numbers, we get minus 6. Well, that was too high. We crossed over 0 somewhere between the 5% and the 8%, so it's somewhere in between. Well, let's try 7%. And if we plug in the factors from the table, we get a result of 0. Therefore, the internal rate of return is 7%. And we were lucky here. It happened to hit exactly on one of our table values, but it was a contrived example, but you get the feel for what this trial and error method is like. Let's go to slide number 9, and we're going to look at another example, but this time we're not going to be so lucky with getting an exact interest rate. In example 7-3, we have a series of cash flows that don't match any of our known patterns, not a uniform series or a gradient. We have to use trial and error, but we've got a lot of different factors here. But if we go through and we find the present worth at, say, 10%, we come up with a net present worth of 10.16. We're using the net present worth equals 0 identity in this case. The 10% was too low. Let's try 15%. The net present worth now is minus 4.02. Well, we crossed over 0, so the internal rate of return is between 10 and 15%. If we look at a graph of what this looks like, and you can see that on your slide, you'll notice that the net present worth is a nonlinear function, and where it crosses 0 is where we have our interest rate, the internal interest rate. And so how are we going to find that point? We've got a number that represents net present worth at 10%. We've got a net present worth at 15%. So what we do is use linear interpolation to find where it crosses the 0 line. If you go to slide number 10, you'll see a linear interpolation formula where all we're doing is prorating and standard type interpolation that you should have used somewhere in your past, and we get an interest rate of 13.5%. Now keep in mind that this is a linear interpolation of a nonlinear function, so our answer is slightly inaccurate, but it's good enough for our decision-making purposes. After all, when you consider that all of our cash flows that we're using for years 2, 3, etc. are all guesses of the future, there's going to be a little bit of inaccuracy there. So a fraction of a percent error in our estimate probably isn't that critical. But let's go on to slide number 11, and let's look at how we could get an exact solution to that using Excel. If you go ahead and put the cash flows in to an Excel spreadsheet in a column, and starting with year 0, you can use the IRR function to calculate the internal rate of return. It's pretty easy to use. It does give you a chance to put in a guess of what the interest rate is for iteration purposes because it iterates to find the answer. If you don't put something in, it uses 0.10 or 10% as a default guess for iteration purposes. Anyway, it turns out that the answer is 13.47%. This is a very useful Excel function because doing trial and error by hand, and you can see how it's done in the book, and you can see what we've done here so far. It's fairly laborious, and you're looking up factors or doing a lot of calculations and then finally interpolating, and it just sort of tedious. But anyway, you can see how they both work. Let's look at another example. Let's go to slide number 12. Now we're calculating the internal rate of return for a bond. In our situation here, the bond we paid $1,000 for. The dividends on the bond are $40 every 6 months. That's a fixed amount we're going to get, guaranteed. And suppose for this example that in 1 year we sold the bond for $950, which is a little bit of a loss, but let's say we sold it for that much. What's the internal rate of return on this investment? If we look at our formula, we have $1,000 equals $40 times the P over A factor, I% for 2 periods, plus $950 times the P over F factor times I%, 2 periods. Now that goes back to our identity that the present worth of benefits equals the present worth of costs. By trial and error, we get that the periodic interest rate is about 1.5%. That's for every 6 months, so we have to multiply by 2 periods to get the nominal interest rate, and we can calculate the effective interest rate as well, which is 3.02% if we use this approximation. So that's the rate of return on this bond investment. You could use that to compare to other rates of return on other investments. Okay, let's go to slide number 13. Slide number 13 is the same example, that's 7-4A, with calculation by Excel. And I just wanted to show you that if you can put in columns for your various transactions so that you can get a total column, then it's pretty easy to use the IRR function to get the internal rate of return. In this case, the periodic interest rate is 1.52%, which results in a nominal of 3.04 and an effective interest rate of 3.06%. Okay, let's go to slide number 14. This next subtopic is called rate of return analysis. It is internal rate of return analysis with a slightly different twist to it. The rate of return name is often associated with investments, and internal rate of return is often associated with internal uses of funds to see what the benefits are within your company. For example, let's say you replace a piece of equipment in-house, you might be talking internal rate of return. But let's say you're buying some stocks or buying some bonds, you might talk about rate of return. There really isn't much difference in terms of calculating, but just kind of a terminology issue. But in calculating rate of return or doing rate of return analysis, we've got some very important points to make here. And let's go to slide number 15 and talk about where we have 2 mutually exclusive alternatives. 2 alternatives that will provide the same benefit. Which one should we pick? We have to use what's called incremental rate of return analysis to answer this question. you cannot simply find the internal rate of return for those two alternatives and pick the one with the highest return. That will not give you the optimal answer. Here is the decision rule we're going to use to determine which of two alternatives would be the preferred one. Now let's assume that two alternatives, both of them have an internal rate of return that's greater than what's called the minimum attractive rate of return. I'll define that on the next slide. In other words, we have two alternatives that on their own, individually, would be acceptable. We're going to pick one of those two as the best one. The way we go about it is we calculate what's called the incremental rate of return, the delta ROR. If the delta ROR is greater than or equal to the minimum attractive rate of return, then we choose the alternative that had the highest initial cost. If the incremental rate of return, the delta ROR, has a rate of return less than the MARR, then our preferred alternative is the one with the lowest initial cost. So that may seem a little strange right now, but that'll be explained. Let's go to slide number 16. Take a break here to talk about what is the minimum attractive rate of return. It is a number, a rate of return that the company says is the minimum that it will accept on a project or an investment because it knows it can get at least that much from other sources. This number is determined by the financial analysts in the company, and it's provided to those that evaluate projects. For example, when I was working for General Motors, our before-tax MARR that we used the last time I was there was 15%. If we were evaluating a project and we couldn't get a before-tax rate of return of 15%, then they didn't want to do it. Now later on, we'll actually explain how that number is derived because it is useful to know that. But for now, we're accepting it on faith. And by the way, that MARR is the interest rate we were using in chapters 5 and 6, but we never said where we got it from. Okay, let's go to slide number 17 and look at an example. This is example 7-5. We're examining a lease versus buy situation with an MARR of 10%. The lease co-option is a lease of some equipment for 5 years. The lease payment is 3 annual payments of $1,000 each. The second alternative is sale co, and that's where we purchase the equipment up front for $2,783. Both alternatives have a $1,200 a year benefit for 5 years, so they have the same output. Okay, if you look at those cash flows, you'll see that the lease co-option, if we looked at that, it has an internal rate of return of 48.72%. The sale co-option has a rate of return of 32.6%. But what we're interested in is the increment. This is the way we do this, we take the cash flows from the alternative that has the lowest initial cost, and we subtract those from the cash flows of the alternative that have the higher initial cost. So we subtract the lease co from the sale co cash flows, and you can see that then column B minus A, we have a negative cash flow at year 0 of $1,783, and then positive cash flows of $1,000 a year for 2 years. So let's go to slide number 18. Now, again, we simply can't pick the highest internal rate of return. We have to examine the increment. If we subtract and we get the increment, we look at that. We've done that. And if you look at that last column, you'll see that the incremental rate of return is 8.01%. Now, the 8.01% is lower than our minimum attractive rate of return. When the incremental rate of return, the delta ROR, is less than the MARR, we choose the lower cost alternative. Therefore, we would choose the lease co-option because it's the lower cost alternative. All right, let's go to slide number 19. Okay, why did we do this? Why did we choose based on that increment and not based on the internal rate of return numbers for those two alternatives? Well, either one will work, but what we're really asking here when we're deciding between the two is, do we want to spend the additional $1,783 to go from the lower cost alternative to the higher cost alternative? Is it worth it to make that extra investment right now of $1,783? Now, for investing that $1,783, what do we get out of it? Well, the incremental cash flows shows that we get a benefit of $1,000 a year for 2 years. That benefit is the avoidance of 2 years of lease payments. So essentially, if we invest that extra $1,783, we'll get $1,000 a year for 2 years, and the internal rate of return on that is 8.1%. But the company wants a 10% return on its investments. It can get 10% somewhere else. So you would reject the increment. In other words, you're going to spend the $1,000 now to go with LeaseCo, and the $1,783 that you would have spent to go to SaleCo, you're going to invest that somewhere else in your business for at least 10%. And so that's a better way of handling your money than going with the higher cost alternative. So if you understood that, you'll realize that this incremental rate of return analysis is very important. And when you're given two alternatives and you're asked to do rate of return analysis, you have to do incremental analysis. You cannot just compare the two rates of return. Final note on this is that the answer you get with incremental analysis will be the same as the answer you get with annual worth analysis and with present worth analysis if you've done the analysis properly, which includes having the proper analysis period. So if you go to slide number 20, that's just a reaffirmation that you have to have the same analysis period and you have the same considerations as we did before. And if you want to see an example of that, I'm not going to go through it, but you can look at example 7-10. And after you look at example 7-10, I think you'll see that using Excel spreadsheets to work these kinds of problems is definitely superior to doing it by hand. Well, thank you very much. That's the end of presentation number 9.